Example number 5. Ay, mija. Here we go. And if you notice the title here, it's a rational function with a slanted asymptote. Dun, 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 ho! And we know this is going to be a slanted asymptote because, look, n is bigger than m, right? That was our case when we don't have a horizontal asymptote. However, this is going to indicate that we have a slanted. And so we'll save that from when we get to down here. Some pretty exciting stuff right there. All right. So for marker will work here. Let's see. Let's go ahead and start off by always factoring what can be factored, and then we can go along with our problem here. Back to the top here, and we'll get x minus 2 times x plus 1 and x minus 1. So nothing factors, and that's okay, but it's good to have it all factored for us. Y-intercept, plug in 0 for x, right? So if I replace 0, 0, 0 there, I get negative 2 over negative 1, which is just 2, right? So that would be the y-intercept 0, 2. Let me do a little e. So 0, 2 there. X is 0, y is 2. Nice. Now let's go ahead and do the x-intercept. That means we set the numerator equal to 0. Well, since this is already in factor form for us, we can go ahead and do that. So x minus 2 equals 0, and we have x plus 1 equals 0, which implies that we have an x-intercept of 2, 0. And this also implies that we have an x-intercept at negative 1, 0. Very good. Let's see, vertical asymptote. Let's go over here. Since the, it's when the denominator, what x value will make the denominator 0. So that means we set the denominator equal to 0, x minus 1 equals 0, and then we solve for x. So x is 1, right? So that's going to be our vertical asymptote. X equals 1. Now, as we kind of stated in the beginning, there is no horizontal asymptote. Look at the rules in your notes. If the numerator is smaller than the denominator, meaning the degree, 2 is bigger than 1. So since this is bigger than the numerator, that means that there is no there is no horizontal asymptote, right? There's none. However, there is a slanted asymptote, and this is now a brand new concept. I haven't been able to show you this, so you're going to want to pay attention carefully now, and you may want to rewind the video if you guys need to grasp this here. Okay, so this is how we find our slanted asymptote, right? What we're going to do is that we're going to have to use long division. Okay, and so basically we're going to divide the numerator into the denominator, and that's the step every time you want to find a slanted asymptote. Divide the numerator into the denominator. Okay, so I'm going to actually come down here and do that with some extra room over here. And let me just get the problem back for us here. So we're going to have x squared minus x minus 2, and then x minus 1. So this is also another great application of long division, is for this purpose now for slanted asymptote. Okay, so let's do this in. Let's see, x times what is going to give us x squared? Well, it's going to be x, right? So we do x times x is x squared. X times negative 1 is negative x, right? And then we subtract. So that means that this is going to become a minus, and this then will become a plus. So those are gone, wata. Those are gone, wata. And then we have a negative 2 left. And obviously, you can't do x times something is negative 2. So we're actually done, meaning this divided by our dividend right here is just going to be x. So the way that you write that is you just say x minus 2 over x minus 1. Okay, so this would be the answer, right? It would be our quotient, x, minus, and then our remainder, which is 2, over our dividend. Okay? So if you're asking, okay, that's nice. We know how to do that. We learned that already, but where does the slanted asymptote come in? Okay, the slanted asymptote is only your quotient. That's all we care about. We actually kind of just ignore this 2 over x minus 1. Okay, we only look at the quotient. And so our Slanted asymptote is going to be y equals x then. Okay, it's always going to be y equals, and then whatever our quotient is, so like it happens to be x, that's what this is. So that means that we will have a slanted asymptote on the line y equals x, up 1 over 1, up 1 over 1, and it's going to look just like this right here. Okay, so let me just review that again. The way that we find a slanted asymptote, well, first, what determines a slanted asymptote is the numerator is bigger than the denominator degree. See how 2 is bigger than 1? That is an indication to tell us that we're going to have a slanted asymptote. So what you do is you do long division. Do this, which we learned how to do in the first section of this chapter. So we do the whole long division, and all we take from it is just the quotient, x. So it's always going to be y equals, and then whatever the quotient is. And in this case, it's going to be x. All right? And that's how you find the slanted asymptote. That's it? Yeah, that's it? No way. Yeah, I'm telling you, that's all it is. You gotta be kidding me. No, I'm telling you, that's how you find the slanted asymptote. So let's go ahead and plot everything that we have, and let's see if we can figure out what this graph actually looks like, right? So I'm going to do some red here. So let's first start with our y-intercept at 0, 2. There's our y-intercept. We have an x-intercept, actually 2 of them, at 2, 0, and at negative 1, 0. And let's see. Hold on, we have like a little guy right there. We have a vertical asymptote at x equals 1. So we can get right there. So x equals 1. So that, and then we have no horizontal, but we have a slanted asymptote at y equals x, right? So it's going to go along this line right here. I just want to make this straight right here. So I'm going to kind of go like this. Go just like that. Just to the origin. Right? So it goes up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and so that's what we're applying that line there. All right. So something new now. We haven't done anything yet with this slanted asymptote, but this follows the same concept. Now, and what I mean by that is, see there's points over here, and there's points over here. Well, we know that these points have to ride along the asymptote, because that's what the point of the asymptote is that our graph rides alongside of the asymptote. So really, this side's going to look just like this. And there's nothing over here. There's nothing in here. And it's probably going to look like this. I mean, we're going to plot some points right now, but it follows the same pattern as the other graphs because you will never have graphs that are next to each other right here. They're always going to be across. Either they're going to be in here together, here and here, or here and there. Okay, so let's just these little patterns that you're going to start to see right there. So let's see what happens at f of negative 2 and f of negative 3. All right, let's just plot those guys and see what happens. So f of negative 1 and f of negative 2. Let's see what's going on those two guys. And if you plug in negative 1, we're going to get 0. And if you plug in negative 2, we're going to get negative 1.3. So let's just go ahead and plot those in. F of negative 1 is 0. Oh, we already had that. Damn, what the heck? Oh, okay, never mind. And then negative 2, negative 1.3. And just kind of, it's just validating what I was saying, how it's going to get really close here. So I'm just going to go ahead and just draw that in right now. Yeah, it's probably the best one I've done all day, all right? All right. And let's plot a few more points over here. Maybe like we'll try f of 2 and f of 3. So let's try f of 2 and let's try f of 3. So if we plug in f of 2 and f of 3, let's see here. F of 2 would be 0 and f of 3 would be 2. So f of 2 would be 0. I already have that again. Damn, what the heck? All right, guys. Well, I guess that's what happens when I do this. It's like 11:30 at night right now. What the heck? How about f of 3? Let's see. 1, 2, 3, and then go up 2. Oh, I got really close there. All right, let's just do one more then. Let's just try 1, 2, 3, 4. F of 4. So if I plug in f of 4, I get 3.3. So 1, 2, 3, 4. 3.3 and get really close to there. Let's go ahead and draw in our graph. Okay, that one's not very good, but oh well. And there it is. We have our graph with a slanted asymptote. The mystery is no longer a mystery. We know now what it looks like. All right. So there's that guy. All right. So what I suggest now for the remainder of the period and whatever time is left is to start working on the practice problems. So this is just a cut and paste from the practice problems. And so for all the graphs that they give you, make sure that you're finding all these things here. Find the y-intercept, the x-intercept, vertical asymptote, the horizontal asymptote, slanted asymptote. And actually, let me just add in here the holes, okay? Because so this is like a practice exam question. It'll be just like this. I'm going to give you a few of these to graph, and you're going to have to find all these things here, okay? And the study guide reflects that as well. So have fun, get nerdy, and have a lot of fun there. All right, cool, thanks.